Welcome to our Masterclass Whiteboard. Today, we are tackling limits involving square roots. This can be tricky, but I'll guide you through two fundamental concepts that will make you an expert in no time. Exercise 1. Unlocking the indeterminate. A. Limit as x approaches -4 of square root of 3x plus 21 minus 3 divided by 2x plus 8. B. Limit as x approaches -3 of square root of 4x plus 16 minus 2 divided by 3x plus 9. C. Limit as x approaches -5 of square root of 6 minus 2x minus 4 divided by 3x plus 4. D. Limit as x approaches -3 of square root of 13 minus 4x minus 5 divided by 2x plus 6. Limit as x approaches a of square root of f of x minus b divided by c of x. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. 1. The direct substitution trap. When you first see a limit problem, your instinct is to plug the value of x directly into the expression. However, in these specific cases, you often end up with a 0 over 0 result. In math, we call this a form indeterminate form. It doesn't mean the limit doesn't exist, it just means it's hidden, and we need a special tool to find it. Let's take a look at question A to see this in action. The first step is always diagnosing the limit. We start by trying direct substitution, plugging x equals -4 into our expression. At the top, the numerator, we get the square root of 3 times -4 plus 21 minus 3. That simplifies to the square root of -12 plus 21 minus 3, which is the square root of 9 minus 3 equals 0. At the bottom, the denominator, we get 2 times -4 plus 8, which is -8 plus 8 equals 0. Result? 0 over 0. It's the indeterminate trap. But here is the professional tip. Because the denominator is 0 at x equals -4, we know for a fact that the factor x plus 4 is hiding somewhere in both the top and the bottom. Our mission now is to find it and eliminate it. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. Now, let's move to the resolution. Follow these steps carefully, and you'll see the magic happen. Step 1. Multiply by the conjugate. We multiply both the top and bottom by 3x plus 21 plus 3. Notice how the numerator follows the a minus b, a plus b pattern. Step 2. Simplify the numerator. The square root disappears, giving us 3x plus 21 minus 9, which equals 3x plus 12. Step 3. Factor everything. In the numerator, 3x plus 12 becomes 3 times x plus 4. In the denominator, 2x plus 8 becomes 2 times x plus 4. Step 4. Gotcha! We found the culprit. We cancel out the x plus 4 from the top and bottom. This removes the division by 0. Step 5. Final substitution. Now that the troublemaker is gone, we can safely plug in x equals -4 again. We get 3 divided by 2 times the square root of 9 plus 3, which is 3 divided by 2 times 6, which is 3/12. Simplified result? 1/4. Well done! Here is a pro tip for those of you who want to go faster. You can actually use derivatives to solve these limits if you recognize the pattern. The formal definition of a derivative is g prime of a equals the limit as x approaches a of g of x minus g of a over x minus a. If you look closely at our limit, you'll see it fits this perfectly. Let's define g of x equals square root of 3x plus 21. We already found that g of negative 4 equals 3. Our limit can be rewritten as 1/2 times the limit as x approaches negative 4 of g of x minus g of negative 4 over x minus negative 4. This is simply 1/2 times g prime of negative 4. All we need to do is calculate the derivative. G prime of x equals 3 over 2 square root of 3x plus 21. Plug in negative 4. G prime of negative 4 equals 3 over 2 root 9, which equals 3/6, which equals 1/2. Finally, 1/2 times 1/2 equals 1/4. It's a brilliant shortcut if you've already mastered your derivatives. Let's practice again with question B, extracting the factor. This slide shows you a perfect workflow for your exam papers. First, setup. Start by writing the limit and confirming it's the 0 over 0 indeterminate form. Next, transform. This is where the algebra happens. Multiply by the conjugate, the square root of 4x plus 16 plus 2. The numerator becomes 4x plus 16 minus 4 equals 4x plus 12. Factor it into 4 times x plus 3. Keep the denominator in its factored form. 3 times x plus 3 times the square root of 4x plus 16 plus 2. Never expand the denominator. We want to keep that x plus 3 visible. Finally, solve. Cancel the x plus 3 factors. Now you are left with 4 divided by 3 times the square root of 4 plus 2. Plugging in the numbers gives 4 over 12, which simplifies beautifully to 1/3. You're getting the hang of this. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. Attention! Question C introduces a common pitfall. Beware the negative coefficient. When we solve limit as x approaches negative 5 of square root of 6 minus 2x minus 4 over 3x plus 15, we follow the same conjugate steps. However, look at the numerator simplification. 6 minus 2x minus 16 equals negative 2x minus 10. Crucial step. You must factor out negative 2. This gives us negative 2 times x plus 5. Many students forget the negative sign here. Always watch your signs like a hawk. After canceling x plus 5, we substitute negative 5. Negative 2 over 3 times 4 plus 4, which equals negative 2 over 3 times 8, which equals negative 2 over 24. Final answer, negative 1/12. Don't let those negative signs trip you up. For question D, we aim for flawless execution. It's all about speed and precision now. We have x approaching negative 3, so we are hunting for the x plus 3 factor. Apply the conjugate. The top becomes 13 minus 4x minus 25, which simplifies to negative 4x minus 12. Factor out the negative 4 times x plus 3. Factor the bottom, 2 times x plus 3. Cancel the x plus 3 troublemakers. We are left with negative 4 divided by 2 times the square root of 13 minus 4 times negative 3 plus 5, which is negative 4 divided by 2 times 5 plus 5. This equals negative 4 divided by 20. Final simplified answer, negative 1/5. Great job staying focused. Before we continue, dear friends, don't forget to subscribe, like, share the video with your friends, and also leave comments to encourage us to continue making this kind of content. Let's look at the blueprint. This table reveals the secret pattern behind all these roots. Look at the hidden factor column. Do you see the pattern? For question A, x approaches -4, the factor was x plus 4. For question B, x approaches -3, the factor was x plus 3. For question C, x approaches -5, the factor was x plus 5. For question D, x approaches -3, the factor was x plus 3. The golden rule is the hidden factor is always x minus a. If x approaches -3, you are looking for x minus -3, which is x plus 3. Knowing exactly what you are looking for is half the battle won. Finally, here are your exam day golden rules to keep you calm and confident. 1. Always verify the 0/0 trap first. Don't jump into the conjugate method if direct substitution already gives you a real number. Only use the key if the door is locked. 2. Use parentheses generously. Algebra errors often happen when you multiply by the conjugate and forget to wrap expressions in parentheses. They keep your work clean and accurate. 3. Hunt for the x minus a factor. This is your North Star. If x approaches 5, your absolute goal is to find and cancel x minus 5 in both the numerator and denominator. You've done a fantastic job today. Keep practicing, stay positive, and you'll master these limits in no time. Good luck! You've got this.